Okay, let's start with the chapter 13. In this chapter, we will see only two lessons. I won't assign any class for this, but this is coming for the test. And also, why I didn't skip this lesson because our topics that are very important for the SAT. Now, this experiment theoretical probability has three new words from the vocabulary. We have the outcome, that is the possible result of a situation or experiment. That means if we are flipping the coin, a possible outcome has the numbers, and the other possible outcome is the result is had the shield. Now, an event is maybe a single outcome of a group of outcomes. If we are doing by an hour that thing with the coin, well, if we choose only one event, that is the event, as a matter of fact, only one. What is the result of that? And the other one is sample space. That means all the possible outcomes that we have. Okay? We have a child and we have um, the numbers. Now, what happened in this one? Here we have the definition of the probability is P event. We write in the parentheses the kind of event we are expecting. For example, we are expecting a marble that is red. Is P red? Example, the probability to have a red marble from a bag, for example. Now, the probability of an event is a numerical value from 0 to 1. That means the result here is less than 1. It's a decimal. We may do it as a multiply by 100 to get the percent. Now, the result is from 0 to 1. It is from 0 to 0.5, less than 0.5, like 0.49. That means it's less likely to happen. When it's more than 0.5, it's more likely. And when it's 0.5, it's likely to occur or not occur. That means, for example, if we are doing again with the number with a coin, it has the same chance to be the shield and to be the number. But if we are doing, for example, other situation like we are making a cube, a dice to select, we are expecting what is the chance to have a number 6 for a dice. Well, it's 1 of 6 because it has 6 faces, the cube. Now, if we are doing that is less likely. But if we are asking, for example, what is the chance to have multiple of 2 is 2, 4, and 6. That means it will be 0.5 because it will be 3 of 6. But now, let's continue here with this experimental probability of an event. The likelihood that the event occurs based on actual result of an experiment. Here we have it. The number of times of the event occur, the number of times of the experiment is done. That means we are taking a sample. We are taking a sample of this of our universe. Now let's identify this example that is here. It says a park has 538 trees. You choose 40 at random and determine that 25 are maple trees. What is the experimental probability that the tree choosing at random is a maple tree? About how many trees in the park are likely to be a maple tree? Now, here we have two things. The experiment is only choosing 40. That means P, maple. We're using this one. The number of events occur and the number of times the experiment is done. Well, the experiment is done is 40 times. Now, what is the probability to get it? Is 25. 25 over 40. Now, we use the calculator. We may have a fraction, 25 over 40. If we get a 5 of 8, I mean 5 of 8. Well, remember is we will use decimal. It's 0.625. If you want to have percent, you only have to multiply by 100. That will be 62.5. Now, percent, sorry. All this is the information that we get from the experiment. And now that is the experimental probability. Yeah, all of those are possible answers. Let's use the percent. It's 62.5. It's more likely to have a maple tree than another tree. Now, about how many trees in the park are likely to be maples? Now we have all the park has 538. It's simple like this. We only have to multiply 538 multiplied by the fraction of the decimal, 0.625. Let's do it. 538 times 0.625. The final answer is 336.25. But remember, we are talking about trees. We have to keep the whole number. Now, in this page, we have a chart that says what is the probability of rolling a number that at 7 when you roll in two standard number cubes. Oh, dice here. Now, here we have the probability. This is a chart important to understand. For example, how we get this is the numbers we have. Every cube has 6 faces. In one face has 1, 2, 3, 4, 5, and 6. Okay, we are talking about those things. See, we have in one face has 6, in the other has 5, 1. This is the number that we have here. If we have another cube, that is the blue one, there is 1 to 6 holes. What are the combinations that are probably to have? Is in one we have 1, in the other one we have 1, the other one we have 2, in the blue one we have 1. But there is another probability that in red one we have 1, and the other we have 2. Those are separate events. Even the addition is 3 in both, but are 2 different events. Now, let's answer the question. And by the way, what are the possible events that we have is 36, 6 times 6. Because that in this example we have 36. 36 possible events. Now, let's make the question that are here. It says, what is the probability of getting each sum when rolling 2 standard number cubes? Number 8 says, the addition is 9. P of 9. Get a 9 there. Now, that means we have to find the combination that we get number 9 using only 1, 2, 3, 4, 5, and 6. Definitely one is 6 plus 3. The other combination will be 3 plus 6. 2 different events. Now, another combination, what happens if we have 5 plus 4 and 4 plus 5. Now, if we reduce another number like 4, we start with 6, 5, then do it with 4, but it's not possible because the maximum will be another 4, another 3. If we make 5, will be this event. This is only the only possibility that we get. Now, that means are 4 possible outcomes. Now, will be P of 9 will be 4 over 36. And now, that is the probability, 4 of 36. 4 of 36 as a fraction is 1 of 9. And as a decimal is 0.81. That is P of 9. 1 of 9 or 0.01. It's not likely because it's more than, it's less than 0.5. Now, let's make the other example that is with B. Letter B says, what are the possibilities to get a number 2? Okay, the only chance to get a number 2 is 1 plus 1. If that is the only event, because if we make another combination, it will be 1. That means 1 over 36. If that is the simplest form. Now, 1 over 36 in decimal is 0.027. It's not too high. Definitely is unlikely to get a number 2 as a result. Now, what is the other result that we may have is the number 13, says here. See, how we get a number 13? That means P13. By the way, he was P2. For P13, remember the maximum number is number 6. This is the maximum here, the number 6. That means 6 plus 6 is 12. That is the maximum. To get a 13, zero probabilities. That means we get 0 of 36, that is 0. That is the event in letter C. Now, the other part is complement of event. Remember the addition, the maximum is 1. For example, if we are talking about marbles here, we may have, for example, what is the probability to get red marbles? Okay? Imagine that is here we have no green, but imagine that is 40% to get a red marble. What is the probability to do not get a red marble? Will be 1 or 100 minus 40, that will be 60%, or 1 minus 0.6 or 0.40, so that will be the complement. Here we have the addition of the probability to get event plus the probability to do not get the event is equal to 1. Probability of not get the event is 1 minus P event. Now, let's see this one, the number 3. Says, what is the probability that random you choose marble, the chosen marble is not red? Okay, first thing, here we are using the information that is here. A jar contains 10 red marbles, 8 green marbles, 5 blue marbles, 6 white marbles. Hey, what is the probability to choose marble is not green? Well, the important number here that we will take is 29. 29 is the universe that we are talking about. Now, to get red, that means P red is equal to 10 or 29. 10 divided by 29, that is 0.34. That is P or red, 0.34. But P not red is simple like 1 minus 0.34 or 1 minus 10 divided by 29. It will be the same result. I will do the fraction to keep all the decimals. 10 divided by 29. And the final answer is P not red is equal to 0.65. And we want to have it as a fraction, will be 19 of 29, because will be 1 of 29, that will be 19 of 29. In other words, we subtract the other part here.